I'll go ahead and introduce our speaker today, Rakesh Patel. He has more than 15 years of experience as a project engineer, project manager, and engineering supervisor in the industrial wastewater treatment market. He's also the mechanical department manager at ADF and is a licensed professional engineer. So without further ado, I'll go ahead and get the presentation started here and then hand things over to Rakesh.
Thank you, Courtney. Welcome, everyone. Good afternoon to people on the East and Central Time Zone, and anybody from West Coast, still good morning to you. Yes. So we'll get started with the presentation. So here's an agenda of what I'm going to be presenting today. First, we'll look at just a general overview of industrial water treatment processes, so we can establish some background of treatment technologies. Then we'll talk about some drivers for industrial water reuse, recycle. We'll look at some of the metric data for what a typical industrial water usage looks like. We'll look at some metrics on water impact index. We'll look at relevant technologies that are applicable in the water reuse program. We'll talk a little bit about the plan and the approach if you are looking to establish a water reuse program in your facility. And we'll go through 2-3 quick examples of water reuse applications. And at the end of the question, we'll leave about 5 minutes for your questions and any comments that may have at the end of the presentation. So I'll get started. All right, so I'm going to start with a survey here. It usually is useful to know the participant's profile and try to tweak the delivery somewhat to match the profiles. So the question here is, if your facility currently has a recycle reuse program in place. If it is yes, it could be no, or it could be something that you are thinking to do. So we'll take about 15 to 20 seconds and allow people to answer the question. All right, so looks like the majority of participants don't have a recycle reuse program. We have one participant whose facility does have a recycle reuse program. So that's good information to know. So like I said, let's establish some background on typical industrial water treatment. So this is the process side of water treatment. And on the left side of the screen is your feed water, which could be a municipal source. It could be wells on site, or you could be drawing water from a surface water source like a lake or a pond. So that's your feed water or your raw water coming in. And then on the rightmost side is your end use. What do you need water for in your given facility? So you could be using water for housekeeping, obviously for domestic and sanitary use like bathrooms and drinking. You could be using it for utility feeds such as boiler and cooling tower. Some facilities have high pressure boilers, and then some facilities also use water as an ingredient in the product they manufacture. They might have labs on site and things like that. So 4 major technologies are filtration, softening, deionization, and polishing. And down below we have the different equipment that you'd use for this type of treatment. So as you go from left to right, your amount of treatment increases. So this is the process water side of the things. And we'll come back later and use this term, some of these terms when we talk about reuse technologies and examples. So same way, when we look at the wastewater side of things, you can broadly categorize wastewater treatment into 3 different types. It's either chemical, mechanical, or biological means of treating wastewater. So chemical means might be you're adjusting pH or removing heavy metals to precipitation, or you might be oxidizing your organics and inorganics in water, and down below again are the equipment and treatment technologies that you'll use for that. Mechanical means is your filtration, removing suspended solids. Sometimes you use membrane systems to remove dissolved solids. And biological processes are when you use bugs and associated technologies to break down organics and through biological processes. All right, so what are some of the drivers for water recycle or reuse? So first one is there could be limits on amount of wastewater that you can treat or discharge. And these limits could be related to allowable permit levels. A lot of our clients discharge wastewater to POTWs, which is a publicly owned treatment work, usually owned by a municipality or city. And they operate under permits, and there are limits to the amount of wastewater that you can discharge, and then limits to individual constituents in the wastewater. So there are limits to that. But sometimes you also run into limits with the existing equipment. You might have undergone a facility expansion, and your equipment on site that you have right now just simply is not equipped to treat as much wastewater, and you're still producing this wastewater that you have to do something with. So that's one of the drivers at that time you might want to look at if you can recycle or reuse some of the wastewater and reduce the amount that goes out. Second one is there could be limit on the amount of fresh water available. There's always limits when you're drawing from a municipal plant. There's daily max and monthly averages that you have to deal with. So there's very few places where you have unlimited amount of fresh water available. So if you don't have enough fresh water available, you will have to look at reusing some of the wastewater back to the front of the system. We'll see here in a couple of slides that the cost for water and sewer has been going up exponentially all over US. So that is sometimes a driver. And then a lot of our clients are sustainability minded and environmentally friendly, and they want to do their part to help the environment and reduce their impact. So they have, even though it might not be driven by the limitations on water, wastewater, or it's not necessarily as much of a cost issue, they still have a high degree of motivation to reuse as much water as possible. So we're going to look at some of these drivers in somewhat greater detail in next few slides. So the first one is a typical industrial plant water usage. On the left side, I have a pie chart for a typical facility that has water that goes in the product, and an example would be a brewery or a beverage manufacturing facility. The blue portion, as you can see, is the biggest portion of water goes out as product. There's a high degree of treatment associated. Then there's housekeeping, and then there's utility and irrigation and other miscellaneous applications. On the right side are process facilities that don't necessarily use water in the product, but still have a lot of water usage. And in those type of facilities, most of the water that comes in goes to utility feeds such as cooling tower and boiler feed. This is a slide from Ohio EPA, and the last year of data it looks at is 2015. But basically what this is showing is when you look at, so orange curves are the inflation, and blue curve on the left is the cost for the fresh water, and the blue curve on the right is the cost for sewer disposal. And if you look at inflation over the last 20 years, on average, it's about 2.4% inflation per year. But if you look at, if you benchmark that in 1995 and look at how much the combined cost for water and sewer has increased, it's increasing about 5.6% per annum. So water is getting increasingly more costly, no question about it. Here is another chart from National Center for Environmental Information that basically looks at the drought and the floods in US, continental US, over last 20 years also. And you can see that this is a very cyclical process, but between 2012 and 2013, a lot of portions in US had experienced drought. If you remember from watching news or listening to stories. There's also again a period in early 2015 when there was water scarcity in a lot of parts of US, especially the western and the southwest portion of United States. And if you look at the overall trend, even though the process is cyclical, the peaks and the duration on the top red curve, that shows the drought region in US, seems to be increasing in intensity and duration over this period of time. Here's one of the other drivers. This is a very useful metric to look at the amount of water that's used by different industry, what we call water impact index. I'm not going to read through all of them. But if you look at the top two for beverage soft drink producers, you take in about 3 gallons of fresh water for every gallon of product that you're sending out. And for breweries, it's even more. It's about 5 to 7 gallons per gallon of beer that's produced. All right, so what are some of the treatment technologies that you can look at when you are thinking about water reuse programs? So one way to look at this slide is when you look from left to right, the amount of the number of required equipment, the treatment complexity, and the cost of treatment is going up. You start from primary treatment, which is removal of your suspended solids and oil and grease, and on the rightmost side, you're going to try to evaporate and take out most of the stuff, and then in between you have organic removals and removal of dissolved minerals and things like that, which is your secondary and tertiary treatment. So one useful way to look at this is if you plot this on a graph, which engineers like me like to do, is you can see that on the left side is the quality, shows the quality of water. So if you benchmark your raw water, which is again from a municipal well or surface source coming in, if you want to use it for potable water application, then you have to treat it. If you want to use it in your beverage, you'll have to treat it and make it ultra pure, go above that, but I'm not showing that because we are primarily talking about wastewater and reuse. The waste on the other side that is produced is going to be of significant lower quality than the raw water that comes in. If you undergo primary treatment, which is your removal of your suspended solids and FOGs, then it's going to improve the water quality. It's not going to probably improve it enough where you can find reuse applications. You most likely will have to do some kind of secondary treatment. And from there onwards, it opens up avenues to recycle and reuse some of that water within your facility. If you go up some more, then it increases the potential. So as you treat the water more, it's intuitive that the number of opportunities or avenues that open up for reusing that water increases. So I think this is a good point to take another survey here. If you're thinking about establishing a reuse program in your facility, what would be your motivation? And you can read through here. Is it cost related to reduce the existing water sewer costs, or is it limitations that you might be facing on wastewater discharge? Is it lack of availability of fresh water, or sustainability or driver? So we'll take another 15 seconds and allow participants to answer the question. All right, so looks like about 1/3 of the participants are saying that they're doing this to meet the limitations on existing water and wastewater discharge permit. Another 2/3 are saying it's driven by cost, reduce the cost. So it's in line with what we typically see out there when we are talking to customers and designing their water reuse programs. So next I'm going to talk about what should be your approach or a game plan when you're thinking about water reuse program. So very first thing that we would recommend is evaluate what you have. Create water balance diagrams. The type of questions that you want to ask is, what is the quality of water that's needed for various end use in your plant, whether that is for utility feed or whether it's for process or whether it's for water that you use as ingredient in your product, or anything else, you have several end uses throughout the facility, and you first want to establish the requirements on how much water is needed and what is the quality of the water is needed. The second important step is to look at your wastewater. Where is the wastewater being generated? How much wastewater is being generated? And what are the different constituents in this wastewater? So you want to establish that too. So that all comes through this water balance diagram, and I have a couple of examples of water balance diagram. So that shows you the complete picture for the wastewater and the complete picture for the treated water needs in your facility. So that's a very important thing to do, in my opinion. The other thing to look at is what kind of space do you have available to put in new equipment, or where your utility room is, because that plays in a factor to what kind of future changes you have planned in your facility, and how is your demand going to go up or down in near-term future and long-term future. That also becomes important. When you take a portion of your wastewater and you're trying to treat it and use it, or even without treating, you're trying to reuse, it's going to have an effect on the final wastewater that you are going to discharge. So you'll have to think about what is that quality going to look like, and whether it affects how it is currently getting disposed. Obviously, you want to look at the cost impacts and the environmental impacts of this whole exercise. So that evaluation, the upfront evaluation, is very, very important. Once you do that, you have a good picture of the water balance in your facility and what you have available. That is when you want to go out and establish some goals and perform water pinch analysis. Maybe look at how you can reduce the usage of water and optimize or upgrade some of the equipment. And what we call a pinch analysis is establish a higher bound and say, for this particular application, I'm going to try to limit my water usage to this number. So that is setting up your goals. Once you do that, next step is to look at available technologies on how you can take the wastewater that you know the characteristics of now, how you can treat it, and then look at economic analysis too, right? Now, how much is the technology going to cost you? Because there's all kinds of technologies out there that will take any type of wastewater and make it as pure as you want it to be, but it all comes at a cost, and it may the payback and financial numbers may not work out. So it's very important to look at the techno-economic feasibility. Once you do that, you get into some preliminary designs for water equipment and the changes to your facility, and then do the detailed design, including who's the vendor and where's the equipment going to do, and what is the balance of engineering going to look like, and do the detailed design. And that is when you go out and build and construct your equipment, train, and then implement the solution. So this is the methodology that we here at ADF follow, and it works out pretty good doing it in a planned, organized approach that way. So here's an example of a high-level water balance diagram that I was just speaking about. You'll have fresh water coming in. You might have some kind of raw water treatment. You may not. And then down below, you have all your industrial users. From the users, you'll likely have a portion of the water going in, going to some kind of waste collection system. And you may or may not have an on-site pre-treatment system. After you treat it, you might be discharging it out to a POTW, a publicly owned treatment work, or to an outfall. Or you might even take some of the stream as it shows down below and send it to some kind of post-treatment and reuse that water out to the front of the system. Also important to remember to evaluate and consider in this water balance diagram is your stormwater, which is shown on the left side of this flowchart, so to speak. Is you have, based on historical data and your storm flood projections, you have, the amount of water that comes in. A majority of that water is going to go out to an outfall of some kind, but some of the streams, such as streams from a tank farm or process areas, will need to be collected because they pick up oils and grease and dirt and other constituents that you have to treat, and you might have to send that stream to the on-site treatment. And then part of that stream can also go through post-treatment and go to the front of the system. So this is the first step of establishing a water balance diagram, is you want to establish an overall picture for the whole facility. Once you do that, you want to dig into individual unit of ops. And this chart may not be entirely readable for everybody, but basically what this is it shows the source and endpoint for each and every stream and each and every process equipment in your facility where water goes in and comes out. And it has a mass balance with your temperature, the quality of the incoming water, the quality or the constituents in the water going out, and then quantify the data for each stream. So each inlet outlets are quantified. So this is a fairly involved exercise, but it's a very important exercise so that we enter into the water reuse program with a complete picture of what your facility has. So next I'm going to talk about, before you start looking at putting new equipment, maybe one of the things that you want to look at is making sure that the operations for your existing equipment is optimized. For some of you who are familiar with sodium cycle softeners, you'll recognize this as the regeneration curve for a softener. And I've been in a lot of facilities where softeners don't regenerate optimally. So it's a 4-step process. You start by backwashing the softener, then you have a brine inlet step, then you have a slow rinse step where you displace the excess brine from the softeners, and then you have a fast rinse step where you displace the remaining brine and you compact the bed, and the softener is ready for the next cycle to put back into the service. But if you don't have a lot of places use a lot more water than they need to, their cycles are not tweaked. So first step is to make sure that the softeners are regenerating optimally. And then the next step is, this is again a continuation of softener regeneration. You would recognize this as what we call an elution curve. So basically you do this to make sure that what we call 30-30 rule is for at least 30 minutes you have brine with 30 salamander degrees in contact to get efficient regeneration of your sodium cycle resin. And in here, basically the purple region that you see, what I'm calling a brine reclaim zone, this is the duration when most of your hardness during the brine injection step is already displaced and it's down the drain. So the water coming out during this regeneration step is fairly clean. So in that step, you can take that water and possibly recycle it back to the brine tank as a makeup water for your next regeneration step. Again, this is based on a project we did, and this can be done at a lot of facilities, but it obviously requires a thorough evaluation. It's not just a straightforward step that I'm not going to make a blanket statement that every facility is going to be able to do this. But you can reuse a significant portion of water in your facility if you are able to reuse some of the water from your softener regeneration process, because softeners typically regenerate every 8 hours and they operate 24/7, 365 days a week. There's thousands of gallons of water that can be reused using this approach, and it doesn't require any amount of extended treatment. Sometimes we put a filter on the line to catch any suspended particles, but that's the extent of it. So the payback is pretty quick usually. Here's another example. A lot of process facilities have to do CIP, what we call cleaning place. And in older facilities, you see a single tank system that we are showing on the left. And CIP can be a 3 or 4 step process where you do an initial rinse, then you might have an acid and or caustic rinse. You might also do a sanitization step at the end of it, and then you have a final rinse where you're displacing all your chemicals and getting the process equipment ready for the next round. So the way it goes is you bring in fresh water in a CIP tank, and you have a pump and heater and a filter, and there's a CIP loop that's shown on the left side where that goes to your process equipment being cleaned, and then the dirty water comes back to that tank. And each one of the 4 steps that I mentioned before, the first rinse, the acid caustic step, the sanitization step, at every step in a single tank system, you have to dump the tank down. So that is where a lot of water usage is. So a possible solution is shown on the right side is you do multi-tank system. Obviously, this is going to require more space and is a little bit more expensive, so you have to do that evaluation of how much you're spending more in terms of equipment and how much water you're going to be able to regenerate. But the water that's accumulated during the rinse step can be collected and can be used for the initial cleanup for the next CIP cycle in a multi-tank system like that. You can, to further optimize the process, you can add a flow meter and you can add instruments like conductivity and temperature. So that gives you a gauge for the water that's coming back and gives you a high level of confidence on your ability to reuse. This one I'm not going to dwell too much on this slide, but this shows cleaning optimization. On the left, you have spray balls, which use a higher amount of water. It's initially lower cost, but doesn't give you as clean a system. A rotary impingement is a somewhat newer technology where you see the diagram at the bottom. It gives you a lot more efficient cleanup with a lot less water. You obviously need to have either, if for larger size impingement, you need to have motorized nozzles and you need higher header pressure, so there's trade-offs there. But this type of technology selection will reduce the amount of wastewater that you generate and use. So here's some examples of some wastewater sources that you can reuse. Softener regeneration, the first one we already talked about. You can also use it in low pressure boiler feed directly, possibly. If you have a demineralizers that you regenerate on site, the rinse water from that can be used to make up the high pressure boiler water. If you have ROs on site and you're softening the water before feeding to the RO, that water can possibly go to your cooling tower or dust control system. Your wastewater with minimal amount of treatment, you can use it for equipment washdowns and things like that. If you have a wastewater RO, you can possibly send the water to fire water or process dilutions. And then we can also look at the condensate return and see how much condensate you are returning back to the front of the system. And if you increase the amount of condensate, it not only saves you water, it also reduces your energy cost because you don't have to heat as much fresh water coming into the system. So these are some of the examples of water reuse applications. So I'm on my last slide now, and then we'll open up for questions. But basically, the approach that we are recommending is start with an evaluation of what you have, create water balances, identify what your end use requirement is, identify what do you have in your wastewater, how much wastewater do you have. Also look at impacts of different chemicals that you have present in your wastewater, because one example is like if you have boilers and you feed amines for corrosion control, those are toxic, and if you're thinking about reusing some of that water in domestic application, then you probably want to think about how that impacts where you're trying to reuse it. Establishing clear goals and doing that upfront analysis to find out what technologies and what they're going to cost is very important, so that you don't go down the path of trying to implement a program and then you find out halfway through that it's just too expensive and you're not reusing as much water, and then the project gets shelved. So bottom line is that a thoroughly evaluated approach is very important when you think about recycling and reusing water in your system. And then obviously if it is a new system or you're replacing an existing system, that approach is different than if you have to work with a lot of existing equipment and you're trying to develop a program around it. So that's kind of a quick overview of what things to consider when you are looking at reuse opportunities. And with that, I'll hand it over to Courtney and we'll take questions.
Okay, let's see if we've got a couple questions coming in. So we'll get through these quickly, and if you continue to think of anything, please use your chat function or your questions function over on the side of your presentation screen to send us a question. So first up, we have how can I reuse RO reject for cooling towers?
Okay. So if you have a reverse osmosis system on your site, most likely you either have a high pressure boiler or you use water in some kind of product. And RO feed water needs to be treated for hardness so that it doesn't clog up membranes. A couple of ways to do that is using anti-scalant or softening the water. If you use anti-scalant, then you need greater post-processing before you can use that water in your cooling tower feed. But depending on your total dissolved solids in your RO reject, which you can determine through an water analysis, if you're softening your water up front, then the chances of being able to use that in a utility feed application like cooling tower is higher. But again, like I said, it's a case-by-case approach that you have to evaluate. But it's very doable.
Okay. Our next question is, how does this compare to zero discharge?
So zero discharge is not necessarily recycle reuse technology. Zero discharge is typically driven by limitations to how much or where you can discharge your wastewater. A lot of remote facilities don't have any treatment plants nearby where they can send their wastewater. So they have to look at zero liquid discharge, which involves membrane systems and evaporators and crystallizers. And it is a compulsion for them, since they are not able to discharge anything, it's a compulsion for them to reuse that water, and that becomes a side benefit. But you can establish a very credible reuse program without a zero liquid discharge program. You can still discharge a good portion of your wastewater after taking out a stream and reusing upfront, but you don't have to go all the way to zero liquid discharge, which can be very expensive.
Okay, thank you. Are there any other questions before we get on to final comments? Great. Well, if you think of anything later, you'll see Rakesh's contact information up there on the slide right now. That's our main office number, so just call in and ask for Rakesh, or you can send him an email at rpatel@adsengineering.com. And of course, you can go to our website, adsengineering.com, and search for any kind of information you might be interested in. So just to finish up here, I'd like to thank everyone for attending. Thank you for your time today. And please watch your email this week for some follow-up items. We'll be sending out a survey. Let us know what you thought of the webinar, how we did today. And also, we'll be sending out a handy checklist for you to use to assess your own water use and potential for improvements. So if there are no other comments or questions, thank you for your time, and we will end this now.
Thank you.
Thank you. Goodbye.